Okay, hi. This is the about the LeetCode question 289 Game of Life. So there are certain rules for the Game of Life. I think it was come up with John Hart and Conway. The basic rules are that you have an n by n grids of a cell, where each cell has initial size. There are the main game would be that it would iterate a lot of times, and it'll try to see what happens in each and every generation. This has no further input required. You just give the initial state of the game, and the game plays itself. Uh, the rules are set up so that the game plays itself. I think this is a very good article which tells about it. The basic rules are that any live cell with fewer than two live neighbor dies as if caused by the underpopulation. If you have a live cell and you don't have any two live neighbors, it dies. Any live cell with two or three live neighbors lives to the next generation. Let's say if you have two or three live neighbors, um, that cell seems to be living. Any cell with more than three neighbors dies, and any dead cell with exactly three live neighbors becomes a live cell. So if you have a dead cell, you can make it alive if any of the three uh, neighbors are alive. So what we are asking is what would be the matrix after one generation of the game, or uh, uh, one entire cycle of the game? What would be the next state? So yeah, we are trying to solve this problem. We'll take in the uh, example one as the input, and we'll try to solve it. So the basic question is that you have an input, which is the board, and we are expected to get an output which is of type which looks in this fashion. So let's try to flush out the solution for this. So yeah. So first things, what we need are int rows is equal to dot length, int columns equal to port dot zero dot length. So these are the total number of rows and columns. So what we do is we try to create a another int array mock is mock is mock equal to, it will be the number of rows for int I equal to 0, I less than rows, I plus plus, what would be that mock I equal to new int array of columns length and array dot copy uh, board, board dot I comma mock I comma all columns would be the length. So it copies, and we created a just one more mock of the copy of the entire board. Now what we do is we try to loop through the whole board for row equal to 0, so row less than rows plus plus for int equal to 0, all column plus then column 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 plus plus. Now what are we checking? First thing we check is that if board row column is equal to 0. If it is a dead board, if else, if it is not a dead board. Okay. So what we have to find is we have to find the um, live neighbors to a dead board. So what we do is int uh, live neighbors is equal to get live get live neighbors. You give it in row column board. Okay, let's quickly solve this. Okay. Mhm. Live live word count is equal to we initialize with low check south if you have to be checking south, right? So row plus one less than. Okay, let's take this int rows is equal to board dot length int columns is equal to board length than rows length and board row plus one column is equal to 1 plus this would be for checking south. Let's check for north now. Say RTH. North would be row minus 1 um, greater than or equal to 0. Row minus 1 north south. Now let's check uh, east. East would be column plus 1 columns. Same way, we'll try to check for east, south, east, west now. Okay, this would be minus uh, greater than or equal to 0, then minus 1 by neighbors. We are checking northwest, east, south. Now let's try to check Start with the red. South, south, east. Okay, let's look at it. Would be something like this only. South is row plus one. South east would be row plus one, column plus one. Okay, so that means it should follow this condition and this condition. Southeast. Next we'll have northeast. Northeast. Northeast would be minus one, minus one. Next would be southwest. South. South would be minus one. Okay, this would be, so column is one, row minus. Okay, northwest. It will be northwest would be we have north, row, okay, let's do it in this way. If board, um, row plus one, column plus one, row minus one. Okay, row plus one less than rows and column plus one less than column. This would be row minus one greater than or equal to zero and column plus one less than all columns. Okay, This would be row plus 1 plus then rows and n column greater than or equal to 0. This would be row minus 1 greater than or equal to 0 and column minus 1 greater than or equal to 0. Okay. Once we got them, then we do return live neighbor count. We have the live neighbor count. So we get the live neighbor count over here. The first condition was that a dead cell with exactly 3 becomes a live cell. If equal to 3, then what we do is mock row column is equal to 1. Okay. Else what were the conditions? If live neighbors less than 2, mock row column equal to 0. Okay. Else if 2 column equal to 0. Mhm. Okay, this seems to be not working. So what do we do is this seems to be copying it. Mhm. We test it out once. Yeah. So the basic explanation is that in the game of life, we have a values for rows and one. We create a mock or a copy of that whole array. We iterate through the current array. We check if it's an zero type or a one type. If it is zero type, it means it's dead, and we are trying to check whether if we can make it alive. The only condition for dead is that if you have three uh, neighbors, that means that you can be alive. Um, for living neighbors, there are few conditions. One is that the count of live neighbors are less than two, then that object that creature dies. And if there are neighbors who are more than two and less than three, either if you have two or three neighbors, what we do is you stay alive because you're staying in the pack. But if you have more than three neighbors, it means that there is no place to grow and you die. So this is that fashion. So what we do is once we computed our mock array, we just uh, paste the whole mock array back into the board array. So yeah, let me copy this and just okay, remove and copy. Okay, so yeah, it seems to be working. So let me submit it in test. Yeah, it seems to be solved and it seems to be working. Yeah, that's the solution for the current problem.